Hello, everyone. Welcome back to our lecture series. Emeka Udenze is speaking once again, and today we will be looking at amines, chemical properties. So, our major discussion will be squarely based on the chemical properties of amines. Let's take it up immediately from there. As usual, I have a beautiful quote for everyone. This time is a much more or less scientific quote about the atmosphere, about the ozone layer. Let me talk about Mario Jose Molina. Mario Jose Molina is a Mexican chemist who played an important role in the discovery of the ozone hole. The bulk of his research was centered on how man-made CFCs, chlorofluorocarbons, deplete ozone layer in the atmosphere. And as a result of his work, he was awarded a Nobel Prize in Chemistry for his work on the depletion of ozone layer by chlorofluorocarbon. So he is a renowned chemist, and this time from a Latinx origin, ethnicity, or more or less. So he says, much remains to be learned about stratospheric chemistry, and in more general terms, about the physics and chemistry of the global atmosphere. Mario Jose Molina Enriquez. That's actually his full name. So he is somebody that is actually worth celebrating, having defied every odds as someone who was born in Mexico to rise up to become a Nobel Prize laureate in chemistry, for that matter. All right, let's immediately start our lecture. Today, our major learning objective will be to know how we'll write the equations for the dissociation, acid-base reaction, and amidation reactions of amines. So the three reactions of amine we'll be looking at is the dissociation, acid-base, and amidation reactions. Let's immediately take it off from there without wasting time. Let's start with the first one, dissociation reaction. See, all amines are, remember, amines are organic bases. So, in other words, they behave as weak bases when they are dissolved in water. And what do you know bases for? Bases are known for accepting hydrogen ion from water molecule when they are dissolved. And when they do that, they do what? They form an ammonium derivative. So they dissociate to an ammonium ion, an alkyl ammonium ion actually, because remember the carbon group is there, and giving off hydroxyl ion. So when, of course, they are the bases. So when they, look at what happens here. When they dissolve in water, this hydrogen, of course, water is acting as an acid. So as an acid donates the hydrogen to this to form this alkyl ammonium ion. In this case, of course, if this is the base, you see this and this has more hydrogen than this one. So this is going to be the conjugate acid. So they form the conjugate alkyl ammonium ion, whereas this now becomes the conjugate base. Remember, we covered this in the first part of this class. Now, in the opposite reaction is what happens, whereby this is now the acid, and of course, the acid is going to donate this one to form water. But our interest here is in the what? In the forward reaction, the one on top here, whereby the base, or in this case, an amine, which behaves as a base, accepts a proton from water to form an alkyl ammonium ion, and the hydroxyl ion is liberated. So the reason why this reaction happens is because amines are weak what? They are weak bases. And of course, you know, when that happens, now nitrogen, like I said in the beginning of this class, is that nitrogen, in the beginning of amines, when we start talking about it, is that nitrogen usually have 3 bonds and 1 lone pair. So in this case, it has 4 bonds. So it all means it has excess of bond, and that makes it to develop an extra positive charge. So if I want to show you that, now if I draw the structure of that guy, that is, okay, that should be nitrogen. So look at what you're going to have. You're going to be having, normally this is what you have. This is exactly what you have here. So when it accepts extra hydrogen again, it develops that positive formal charge. Remember, formal charge is equal to valence electron minus the sum of the dots. Dot is the lone pair, is the number of dots plus the bond. In this case, there's no dot, so only we have 4 bonds, 1, 2, 3, 4. And nitrogen is in group 5, so 5 minus 4 is going to give us +1. And that is how this formal charge develops. And you're going to be seeing this more or less, because most of this reaction associated with amines will be the formation of either the ions or this ammonium, of this ammonium ion and the salt as well. So let's complete this reaction. In this example here, look at what is going to happen. Now, this is of course methylamine. Remember, when I'm talking about reactions, I don't do nomenclature, but I can also tell you the names without having to write. So this is a methylammonium. Sorry, not methylamine. This is a methylamine. This is methylamine, which is a primary amine. In this case, we receive hydrogen ion from water here to form methylammonium ion. So it takes one to become this, and therefore develops the formal charge. Plus, this one loses one hydrogen, is now going to become OH minus. Of course, like I told you, this is methylamine. This is water, of course. This is now, you call this methylammonium. So if you want to name this ion, like I told you, it's aqueous. So you say methyl, let me put this here. So this is methylammonium ion plus the hydroxyl ion. So this is how you write these reactions. And to drive this down, we're going to do some few reflection questions. But before then, it's important I state this. So the pH of blood, of course, at the physiological pH of blood is about 7.4, which is a little bit slightly basic. In these conditions, most amines that exist or that found in blood is present predominantly as the conjugate acid, which is predominantly as a protonated or conjugated acid. Protonated means it accepted a proton. So example, this is a dopamine. Dopamine is actually a drug. Now, this drug doesn't usually exist this way if you find it in the blood, or even when it is being administered as a drug. Look at what happens. This hydrogen will now go and be donated to this to form NH3 plus hydrogen ion. So this now becomes, remember, this is the base, and this is now the conjugate acid form, which is the major form in which this particular drug will exist in the body. So it's going to exist in this form at that physiological pH. So amines will exist as a protonated conjugate acid form in solution of water or blood. Now let's take a few reflection questions to drive home this point so far. Now, in this reaction, again, I told you this hydrogen is going to go here to be attached, and when that happens, of course, this is trimethylamine, but I don't need you to name it. So what are you going to have? You're going to have this N here. You're going to have this CH3. You're going to have CH3 here. Of course, this is going to accept one hydrogen to become plus. You're going to have your OH minus. So, of course, if you want to name this is going to be should be trimethyl ammonium ion. Ammonium ion. Of course, this is trimethylamine. Remember that. This is tri is I. Trimethylamine. That's how you name this. Now, we now do the second one. In doing this one, the same thing here. This will be donated to this. Again, of course, this is cyclohexenamine. So you're going to draw this ring. And then you put this. This is going to be NH3 plus OH minus. Remember, this is plus here. So again, this is cyclohexenammonium ion. That's how you name that. So this or let's not need to name it. So okay, let me just write it. I'm not going to give you something this complex. Cyclohexylammonium ion. That is how you name that if I ask you to. But most likely I'm not going to ask you to name this directly. Okay, let's go to the next reaction. Acid-base reaction. Acid-base reaction is because of the basicity of amines. And of course, every acid-base reaction is also called what? Neutralization reaction. Don't forget. Neutralization reaction. So all amines behave as weak bases. And what do? They form salt when they react with acids. And they do that with both organic and inorganic acid. Now, in the general reaction, look at what is happening. This is amine, which is a base. This is an acid, HCl. This is hydrochloric acid. What happens? This guy, every acid will donate its proton to the base. That's actually what acid for. They donate this to this guy to form. Of course, it's going to form what we had before, what we did when we did the dissociation. But in this case now, the chloride now forms part of it. So it forms an amine salt. If you don't want to call it amine salt, it's also can be, because it's as an ammonium, it can also be called an ammonium salt. So it's an ammonium salt as well, because this is kind of ammonium ion there. So that's what you have at that point. So it forms either amine salt or an ammonium salt. And one thing very, very interesting about the amine salt is that they are very soluble in water, because they are what? They're ionic compounds, and they do have some properties of ionic compound, which include high boiling and melting point, and then high solubility in water. So to have an example, let's complete this one here. The same thing will happen. Now this is methylamine plus the acid. If this goes to this guy, you're going to have this. This is going to gain this to be NH3. Of course, you're going to put the plus here. Plus. No plus there. Then you're going to write the chloride ion will be by the side. So this is now the methyl ammonium chloride. Actually, this is methyl ammonium chloride. That is how you name this amine salt. And of course, this amine salt is an ionic compound. And of course, it is what? Soluble in water. Do not forget that. Do not. This is supposed to be a comma so that to be clear. Yeah. All right. We now take a few examples after this illustration. So, of course, still talking about the basicity of amines. Amines, whether soluble or insoluble in water. So, some amines, remember, small molecular weight amines will always be soluble. So, whether they're insoluble or insoluble in water, the higher molecular weight ones, when you react it quantitatively with strong acid, they form water-soluble salt. Like I just showed you here, they form, this is the salt. This is the methyl ammonium chloride is an ammonium. Remember, this is an amine salt that is soluble. So that is exactly what happens. So, and that is actually exploited in drug designs. Most of the drugs that are amines. Now, when they're gotten as amines, if they have molecular weight amines that are insoluble, what do? They react them with acid to form water-soluble amine salt. And it is that form of water-soluble amine salt that these drugs are actually administered in the body. So to complete this reaction, of course, this hydrogen will go here. And when that does happen, this will now take it to form the ammonium ion there, and then you put the chloride by the side. Look at the action. So now this is the insoluble amine. This is water-soluble amine. And this is the insoluble amine. This is the water-soluble amine salt. Of course, I told you it is what? An ionic compound. Do not forget that. It is an ionic compound in shortcut. All right. And this is general for every amine, actually. All right. So taking some reflection questions to drive home this important point. Let's do that. Say complete the following acid-base reactions. Now, of course, this is organic acid. Now, remember, this will be our base. This is the organic acid. This is actually ethanoic acid or acetic acid. This is ethanoic acid or acetic acid, whichever one. This is aniline, of course. This is an aromatic amine. This is aniline. Don't forget that. This is aniline. Now, when you react them, so what's going to happen? It is this hydrogen that is going to go here. I have to use my red. Okay. And what happens? I'm going to redraw this guy. If you redraw this, and then put this guy here. So now this is going to gain one other one to become plus here. And then you're going to now put this, the acetate ion. Acetate ion is CH3, COO minus. do not put the acetate ion. And of course, so this is what? An amine salt. And in fact, this is called phenylammonium acetate. You don't need to name it, but at times I put this just to help the understanding the better. And this is soluble in water. The same thing happened here. This is triethylamine. This is actually triethylamine is a tertiary amine. Triethylamine, because there's ethyl here, ethyl. So this triethylamine. So what's going to happen? This hydrogen will go and connect here. Again, you're going to have this. So you're going to have CH. So you're going to have CH2, CH3, CH2, CH3, CH2, CH3, and then the hydrogen connecting from here, and this is going to have, because 4 bond is there, it's going to have a positive, and then you're going to put the fluorine by the side. So now, so this is now triethylammonium fluoride. Actually, this is this is because there are 3 of them. This is triethylammonium. So the difference here is change this amine here to ammonium. That's only what you do. Triethylammonium, and then you put the name of the what? Of the negative ion, which is fluoride. You name it as though it is an ion, which it is an ion itself. All right. So this is how you do this problem. Feel free to pause this video, work out these things on yourself, and come back and see how I did it and check for proper comprehension. We'll now go to the amine salt that I've been naming. So how do we actually name amine salt? I've already named them here, but let me just also put this thing forward. So they are named by changing the amine. Okay, let me use this. They are named by changing the name amine to ammonium. That's what you only do. You put the alkyl group, you put ammonium, and then you add the name of what? The negative ion that is derived from the acid. Like we did here. I put this is triethylamine. So I now put triethylammonium. That's what I only changed, and put the name of this fluoride ion here. So triethylammonium. That's exactly how you name this. So they have physical properties that is similar to those of ionic compounds, which is what they are. They are white crystalline solid with high boiling. They have high boiling and melting point. They are more soluble in water than their parent. They are more soluble in water than the parent amine from where they are made from. And in fact, most amine drugs are made soluble by reacting them with an acid to form soluble amine salt. In fact, majority of the drugs administered, most of them are amines, and they are only because these amines are high molecular weight that are insoluble. So to make them soluble, you react them with an acid so that they can form amine or ammonium salt, and it is the form of this ammonium salt that these drugs are being sold. So example here is the one I have before. So this is triethylammonium chloride. So this is the chloride here. This is the 1, 2, 3 triethylammonium chloride. To name this one now, okay, we're going to alphabetize. Look at the attachment, methyl and propyl. Which one comes first? Methyl. So it's going to be methyl, propyl, ammonium, acetate. Acetate is the negative ion. This is negative ion. This negative ion is the acetate. So it is methyl, propyl, ammonium, acetate. That is how you name these ones. So now, in reflection question 3, it says, given, now you are the judge in this case, you are in the lab, you are given hydrogen, hydrochloric acid, and sodium hydroxide as reagent. And it says, which one of the above will you use to react the following amine? This is an amine below, to make it water soluble. It says, put the reagent, look at the question now, put the reagent on top of the arrow and draw the soluble form to the right of the arrow. So now, amines are bases. So amines are bases. So for you to react it, you are going to react. You cannot use sodium hydroxide because it's a base. A base cannot react a base. So a base will react an acid. So you have a base, you're going to react it with the acid. So we're going to be using what? The HCl. So I'm going to put the HCl on top of this arrow. And what do I do next? And I redraw because this HCl is going to go and then the hydrogen will be donated to this nitrogen here, and then the chloride ion will now go and join it to form the amine salt. So if I redraw that, what am I going to have? In redrawing this, I'm going to start with this ring here. The ring is conjugated with another one with this one here. Now I'm going to put this guy here, and then I'm going to put the OH here, and then I have this here, go this way, this is here. This is all you have there that did not change. That is not the reaction. The reaction center is only at this point, so that is now where I'm going to focus lastly. So you have nitrogen there. This hydrogen will go and join, so it's going to be now two hydrogens. You're going to have two hydrogens there. And if you have two hydrogens, remember you have this here, and then you're going to have your chloride ion. So this is exactly what is going to be forming. It's going to be forming this. So you're going to have these two hydrogen here, because one started one becomes two, and because of that it now has 4 bonds. So in that 4 bond you have to add what? A plus. Remember, we're not going to have a plus. So this is an amine or ammonium salt. This is an amine salt, and of course it is now water soluble. And of course, if you're a pharmacist or a chemist, this is the form in which these drugs will be sold. Exactly. So having done that, we're going to be going to the next reflection question. Like I said, always feel free to pause this video, try out these problems yourself, and come back to check for comprehension. Now, in reflection 4, this is a theoretical question. It says, in order to dissolve in the body, medications, that's drugs now, drugs or medicines, must be water soluble. It says, which of the following types of nitrogen containing molecules is the most water soluble? Amides, amines, amine salt, they are all approximately the same water solubility. So which one? You have the answer. We've been talking about it, amine salt. So it's going to be amine salt at the most water soluble. And in fact, most drugs are made and prepared in this form and administered for use. All right. So we now go to the last but not the least of the reactions, amidation. Amidation is also an acid-based reaction, but it's a different type of reaction in this case. In this case, it's a reaction between an amine and an organic acid. Of course, our organic acid is carboxylic acid. So reaction of carboxylic acid with amine is what we call amidation, because it forms amide. So let me read what I have. It says the reaction of a carboxylic acid with an amine, removing OH group from the acid. Remember, the acid has the OH group, and removing hydrogen from the amine. Now, if you add OH plus H, it forms water. So what it means is that you are removing one molecule of water when amides are formed. So when you remove the OH from the acid and H from the amine to form an amide, you now give off water. So I can put it plus water molecule. That's, you form water in that process. So this type of reaction is a condensation or dehydration. Dehydration means removal of water. Condensation means you are bringing two things together to form one stuff. That's exactly what is happening here. So it is not a typical acid-based reaction. It is not an acid-based reaction. This particular type of reaction is actually catalyzed by enzymes in the body, enzymes in biological systems. They are catalyzed by enzymes in biological system. Enzymes are actually those facilitators of this type of reaction. And this type of reaction must be between an organic acid, not inorganic, organic acid and an amine to form amine. And in fact, if I'm going to ask you this in an exam, to separate it between the other reaction, acid-based reaction, I'm going to give you a hint. I'll say complete this reaction, acid-based, or complete this reaction, amidation reaction. So just to let you know. So like I said, if you remove this and this, you form water molecule. However, what is happening? Now, what is happening here is that this nitrogen will come and join this one to form one compound. Look at what happens. All this side is unchained, but this nitrogen will come and join this one. Remember, it has lost one of these. You still have your hydrogen here. Of course, the lone pair is here. Remember, the nitrogen always have 1 lone pair and 3 bonds to be neutral, actually. So, forming this compound. So, this is what we call the amide bond. This is actually the amide bond. That is characteristics of amides. So, of course, what we have here is, in this case, we have ethanoic acid or acetic acid reacting with methylamine or methenamine, whichever one you want to call it in IUPAC, to form this amide. This amide is actually called, to name amide, we're going to do it, but this amide is actually N-methyl, because it's attached to carbon, this nitrogen, N-methyl 1,2-ethanamide. This is ethane, because this is, from here is 1,2, so which is ethane. Ethane, then I put amide. That is how you name the amide. But do not worry about them at all. We're not going to name them now. The old name is N-methylacetamide. We're not going to name them now because we've not done that. We're going to come there. But this is just an IV or eye opener to prep you by the time we actually get there in reality. So this is what we call the amidation reaction. The amidation is a dehydration reaction that results to the loss of a molecule of water and the formation of amide bond. And in fact, most proteins are made from amino acid. And amino acids come together, join themselves together by forming the amide bond. In that case, we call them peptide bond. And we're going to see this as we move on. So in our reflection question 5, it says, complete the following amide reactions. Or I give you a hint, formation of amide. Or you call it amidation, whichever one that works for you. Now, you don't need to name it. Let's go straight to drawing it. Remember, it's going to give, this one is going to go, and one of these hydrogen is going to go to form water molecule. But my interest is usually in this reaction is to tell me the major product. So let's start. So I'm going to have this like this way, unchanged, this unchanged. Now, remember, this water molecule is gone, but now it has a nitrogen. So this nitrogen, of course, is connected to this guy. Remember that, don't forget that. So, and then, remember, it only lost 1 hydrogen, therefore you still have 1 other hydrogen at that point. So this is actually the amide. This is your amide bond. So an amide bond is when the carbonic carbon is connected to a nitrogen. That is actually our amide bond. Carbonic carbon connected to a nitrogen. So this is what you're going to have. And of course, you're going to have water liberated from that reaction. That is how you complete that reaction. Let's do this one too. For this one, this is a tertiary one, a tertiary amine. Sorry, a secondary, because it still has 1 hydrogen. This is the secondary amine. So reacting with 1, 2, 3. This is propanoic acid. So this is dimethylamine, but we don't need to name it. Let's put it together. You can start with any one first. So this one, I put acid first and did this, so it doesn't matter. So in this one, I can start from this one. So it's going to be, I'm going to put my nitrogen here. So I'm going to, of course, put these guys here. These guys are all there. And this guy, of course, it loses one of the hydrogen. This guy loses this. So this will now be connected, of course, will now be connected to, of course, to this carbon first. Remember, it's going to be connected to this carbon. Okay, let me make it this way. A little bit to look like this. I'm going to take it up. And then I'm going to do this. And then I'm going to do this and this. Just so that it looks a little bit like what I have there so that I don't confuse you. So if you count 1, 2, 3, this is 1, 2, 3. So this is a nitrogen. Remember, this is nitrogen to the carbonic carbon. This is nitrogen to the carbonic carbon. And of course, you're not going to put another hydrogen here because this already has a 3 bond, because this is the tertiary amine. So it only has 1 hydrogen, which it lost. And then, of course, when you combine this and this, you're going to have a molecule of water. Of course, that is how you complete that reaction. Again, always feel free to pause the video, try out these problems yourself, and come back and check it for comprehension. We now go to the next reflection question. Still, in this case now, I'm bringing in amino acid. This is the reaction between 2 amino acids. Actually, this amino acid is called cysteine. A cysteine amino acid, this is actually called serine. This cysteine amino acid is called a sulfur-containing amino acid, and is actually a polar neutral amino acid. You don't need to get into that. This is also a polar neutral amino acid, but you can also call it an alcoholic amino acid because it has an OH here. So we call it an alcoholic amino acid. An amino acid with the OH group. This is an amino acid with sulfur group. So now when they combine together, now this is not the places that react. The places that react, remember, amines react between, look at the side that react. Okay, I'm going to use a different color. Now, the carboxylic end of this amino acid and the amino end of this one. We actually call this the C terminal. The C end and the amino terminal end. That's usually what we call it. So when you put them together, they're going to form a dipeptide. Two amino acids combined together will form a dipeptide. So let's see. We'll start putting it together. So now, this one will remain here. Nothing happens at this point. This hydrogen is there. This, of course, is there. Now, this is where the reaction is taking place. What is being lost? Okay, let me use a different color. You're losing this now. So what it means is that I'm going to have C. Oh, no. I was supposed to change back to the color. Now, so you're going to have this C here. And then this C will now come and get connected to this nitrogen here. Of course, this nitrogen still have one bond. But it has lost one of the hydrogen to form water molecule. So what do? We'll now finish this part. So this will now be connected to this one here. And of course, this will give us this. Nothing happens here. And of course, this. Oh, I didn't finish this. So this. Now, so where is the amide bond? Let me show you. This is the amide bond. This is the amide bond. And this amide bond, in amino acid, in proteins, it is called the peptide bond. And this is a good prep by the time we start talking about proteins. This is the peptide bond. A peptide bond is an amide bond, whichever one. So now this molecule, remember this is an amino acid. This is an amino acid plus an amino acid combines to form two amino acids. And these two amino acids, we actually call it a dipeptide. And in fact, this dipeptide is called because this is cysteine. So it says cystenyl serine. That is how we're going to name this particular amino acid, which we are not expected to do at this point until the time we get to proteins. But it's good. I'm taking this time to introduce this thing little by little to you. So by the time we get there, you're going to be very much familiar with these terms because I'm still going to say them again. And having said that, we'll be coming close to the end of this lecture to summarize. Now, to summarize, as I've always done with all the reactions, we're going to be ending with a reaction map. In this reaction map, we're looking at the three reactions of amines. The first reaction is this one. In the first reaction, amines react with water molecule, which is dissociation reaction, to form alkyl ammonium ion. Remember, if you say ammonium ion, that's okay, but it's usually alkyl ammonium ions. And then, secondly, we talked about the acid-base reaction. In the acid-base reaction, amines are bases. Of course, you know they are the organic bases. Don't forget that they are the organic bases. So they react with acid, whether organic or inorganic acid in acid-base reaction. In acid-base reaction to form amine salt. And of course, amine salt are soluble. I told you that. They have high boiling and melting points. And they are ionic compound. And we said this is the form that most amine drugs are administered so that they will be soluble in the aqueous medium of the blood. So they are ionic compounds. Remember that. And then the last reaction is amidation, whereby they react with organic acid or carboxylic acid. Remember, carboxylic acid are organic acid. And in this case, is a dehydration reaction. Amidation reaction is a dehydration reaction and a condensation reaction as well. Condensation reaction. So where now they come together to form amide, and of course, giving off one molecule of water. That is what we say is a dehydration reaction. So having said this, we've come to the end of this lecture. Thank you once again for listening. Bye.